found you well. Okay, today we'll be dealing with the acid-base dissociation. So for this tutorial, we'll look at acids. Okay, so an acid, basically, I'm supposed you are aware that an acid should contain an H plus ion and some substance. Normal acids like hydrogen chloride, this would be chlorine, or maybe hydrogen sulfuric acid, this would be the sulfate ion, or even carboxylic acid, this would be the carbonic part, and this would be the H, which is the in there. So whenever an acid is placed in a solution, or when we mix the acid with water, which is the normal way, an acid will dissociate. Dissociation will mean that this acid will actually exist as separate H plus ions and the other part, which is in this case X minus. It's not the whole of it, as you can see. It's a reversible reaction. That implies that some will become H plus and some will remain as HX. So the amount of the acid that dissociates determines the strength of the acid. If a lot of it dissociates, that means that acid is a powerful acid. If, however, a few of the H plus and HX minus X minus ions dissociate, that implies that the acid is a weak acid. So basically, we quantify that using constants. This is the normal reaction constant, whereby we put the concentration of the product over the concentration of all the reactant. However, in the case of dissociation of an acid, the concentration of the H2O or of water is almost constant. Therefore, we can actually remove it safely. Then we remain with the Ka. This is the constant, equilibrium constant of an acid, which actually quantifies the degree of an acid. If this Ka is higher, that implies that the strength of the acid is high. If it is low, then the strength of the acid is also lower. Thank you, ladies and gentlemen.